No, I don't want to save my work. Oh my god, I'm getting eye damage. Ugh, it's so bright. Gah. Please just. Oh my god, thank god this. Okay. This is how I remember Packet Tracer looking. This makes me happy. Oh my god, it can tell what text it is. Okay, what I'm gonna do now is go back to Breeze Dark. Apply. Okay. I mean, this is like good. I need a second switch and I need a third switch. So, we've got host names switch 0, switch 1, and switch 2. Switch 1 is at the top. So S1, S2, oh no, that's 0, blah, 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 blah. S3, S1, S2, and S3. Yay. And now we need to, I'll text the person. Okay. So we now need to create 16 PCs. I will just do that real quick. But then again, it's better for my hand or something like that. Okay, we have like 16 PCs now. Now we need to connect them. Isn't that like exactly what we've always wanted? So fast Ethernet 1, 2, fast Ethernet 1. Okay, I don't know what that does. Fast Ethernet 2, 2 fast Ethernet 2. And fast Ethernet 2, 3, 4, and 5. Okay, this is at least somewhat easy. Now we've got to connect our switches. Switches, which is between S1 and S2 we connect via fast Ethernet 23. I want to select that, please. So we are gonna take fast Ethernet 23, go into fast Ethernet 23 with a crossover cable, and the same for 21 to switch 3. So how good is that? So now we need to check our 24% completion, and I only really made some computers. So I'm gonna, all right, Packet Tracer doesn't have a control A. I'm gonna move this over here a little bit. And I'm gonna move over. You zoom out once. So, I hate Packet Tracer. Okay, so all the switches are connected. What do we have to do now? We have to configure host names. So I'm gonna do that and that and that. And I'll put them next to each other on my too small screen. Smaller. Smaller. Oops. Okay. So, next step. Pretty please my... actually, I want to use the LibreOffice. So, configure the hosts based on the IP addresses from lab 1 and the above network topology. I didn't have to open all the switches yet. Okay. So there's a handout. Sample solution. This one. And we have to configure the networks, or rather the devices on the network, or the PCs on the network for now, with these IP addresses, which I will just do real quickly. Why can't I move my things between my screens? That is so annoying. Okay, PC00. Right, Juno, if there's any questions, just interrupt me. Yeah. PC00. Desktop IP configuration. Static 192.168.0.212. 248. Yay! First IP, PC1. Desktop IP 192.168.0.1. 192. The excitement of entering IP addresses for 16 PCs is unending. Right, next step. No, we need to do this handout. Configure the following on all three switches. Thank God I already opened them. So we're going into CLI. I know that you missed. Okay. So, all three switches. Hostname, I'm gonna do that manually. Password I can do. No, first. Okay, save the configuration. Okay. So what I'm gonna do is open all my three switches for now and say enable configure terminal hostname S2 enable configure terminal hostname S1 enable configure terminal hostname S3. So, and now the interesting part. If you ever work in packet tracer, or really with real hardware as well, you end up realizing that it's really boring to constantly write the same thing. So you write a script to do the thing for you. So I'm gonna put that on my other screen. Actually, I'm gonna do this. Boop and boop. So no DNS lookup. I have no idea how to do that. Is there a back button here that I can? Yes. Exercise 1 cheat sheet. No, exercise 2 cheat sheet. Yes, I know. Hostname, yes. No IP domain lookup. So we're already in config, so no IP domain lookup. Then we have to enable passwords. So set enable password. Enable secret class. Then we'll say line console 0 because we have to set the password for line console 0, which is if you just like connect to a switch, like if we're in the normal in the normal mode here, this is the line console 1. You can see S3con0 is now available. That's the line console 1. That's why we have to configure a password, because we don't want people configuring our switches without a password. So we'll say password plus password Cisco and login and exit. So we're back in the privilege mode or config mode. Then we have to make an MODT. Banner. MODT. Yeah, MOTD. Hashtag. No unauthorized access is allowed. So, and then we have to save the configuration, which is surely also in our cheat sheet. Save. Okay, it's not in our cheat sheet. Oh god, I've not done this in a while. Cisco switch save config. How to save running config? Right, copy. Copy running config startup config. And the big question now is in which mode? Enable config term. Copy. Okay. So exit. Copy. Yeah. Okay. So we have to exit first. Oh my god, I'm getting messages. Wrong. We have to exit down here. And then we have to copy the running config to the startup config. I'm getting pieces messages. That's fun. So now we wrote a script and we can go in config term. And we can paste it everywhere. So just making sure that every switch is connected, and we can say paste. Destination file name, startup config, okay. We'll say paste, destination file name, startup config, okay. Destination file name, startup config, okay. So we configured these things. From PC4, try to ping PC6 and PC1. Why does it work? Why does it not work? Well, we'll figure that out. Because we're good at figuring things out. I'm at 40%. I'm so proud of myself. It's like I did this at school. Command prompt. Ping. And now we need to figure out which IP address is a PC whatever. Sample solution. We should be pinging not from PC1, but from PC. From PC4. Try pinging. Actually, let's just ping. Try pinging PC6, which which is 192.168.0.131. And look at that, it works. It's amazing. And then we'll try pinging PC1, 192.168.0.1. And oh, why does this not work? I wonder why. So, what we just discovered is subnetting. Excuse me. What we just discovered is subnetting. PC1, when trying to ping PC4, when trying to ping PC1, tries to ping an IP address not in its subnet. So, what we can say here is no, PC4 and PC1 are not in the same subnet, thus they cannot communicate. PC6, however, is in the same subnet as PC4, and thus the switches can switch and the PC's PC talk to each other. Cool. That's the answer. Create and assign all VLANs on the network switches, including VLAN 75 as a native VLAN, VLAN 99 as management VLAN, and VLAN 100 as black hole VLAN for the unused ports. What does this mean? Well, that means we're making a new script. So, first thing to note, comments are, I think, written with exclamation mark. I'm gonna check. Exclamation mark ASDF. Yeah, okay. Comments are written with exclamation mark. So we've got exclamation mark. Who is daring to text me now? Okay. We're writing exclamation mark and then the switch. So we're configuring switch 1. We're expecting to be in the config terminal, even though we're probably not in the config terminal at that point. But I'm just gonna have to log into the config terminal. So, config terminal. Config terminal. I need to go into how do you change your status? I would like to be status not available. Okay, sure. Where was I? Right. VLANs. We have to assign all VLANs to the right thingamajigs. So this is thankfully relatively easy. VLAN 1, innovation and development is VLAN 10. That is PC 1 through 3. So VLAN. Okay, and there it ends for me. There is my cheat sheet. VLAN and name. And what is the name? I think just innovation. Exit. I don't think we need exit actually. VLAN 20 name marketing. Actually, we have to do this on all switches, so I'll just leave that out. VLAN 30 name sales. VLAN 40 name support. VLAN 50 name operations. VLAN 99 name management. VLAN 75 name native. And lastly, VLAN black hole name. Oh, oops. Is it obvious that it's 9 p.m. and I'm a little tired? VLAN 100. So, what does this do? This creates a VLAN and assigns it the name innovation. Yeah, that's it. And this does it for every VLAN. So once again, we are opening every switch. Config term. S3 is also config term. And S1, we also need config term. Config term. And then we'll paste it. And then enter at the end. Paste it. And then enter at the end. Paste it. And then enter at the end. So now we should have created all our VLANs And we're already at 72%, which is great. So now I can close these. I probably shouldn't have closed them. I probably will need them again. But that's fine. Assign specific ports to each VLAN according to the topology. Add all unused ports to the black hole VLAN. How do we do that? Well, guess what? There's a thing for that. Namely, when you're in config terminal, you can say interface. Let's write that interface. And then let me just open a switch to check that I'm not stupid. Int range exit int range and then we'll say FA fast Ethernet 0/0 to 2 fast Ethernet 0/24 int ra fast Ethernet, and we'll just shorten this a little bit by saying, instead of writing out fast Ethernet, we'll say FA 024 FA 00, and then we should be able to configure an IP range. FA, nope. Interface not range. Oh my god. 0/ Ethernet interface number. It's FA101 to FA24. Okay. So saying int range FA01 to FA24, we get to configure all at the same time, which means that's not what I intended to do. Which means we can say things like add all unused ports to the black hole VLAN. How do we do that? We say switch port mode access, switch port access VLAN 99, no, at 100. Okay, and then we're good. Then we can go to the next interface, int FA01. So, and now we need to actually decide which switches it is. Let's start with switch 1 in FA11. So now we just need to, it's already an access, switch port mode access. So we just need to say switch port access VLAN, and then we have to figure out which VLAN it is. So we'll go up here. One is VLAN 10. Int FA01 02 switch port access VLAN 20. And I'll just copy that. FA03 is PC5 is also 20. FA04 is PC7, that should be 30. I'll just open the sample solution. PC7 is VLAN 30 indeed. And FA05, why did I write this? Is PC10. PC10 is in VLAN 40. The switch port access VLAN 40. And FA06 is, let's just grab that. Switch port access VLAN, that's the PC15, that should be 50. And lastly, int FA07 is the management PC, which is in VLAN 99. So what are we doing here? First of all, we go access every port. So every port that's on our switch, or every fast Ethernet port, we're accessing and making it switch port mode access. What is switch port mode access? That means that it's a normal switch port with a VLAN assigned to it. And then we assign the VLAN 100 to each of those 24 ports. That should be a 1. So, switch port access VLAN 100, we assign the access VLAN 100. And then we iterate over, or we go over every other port and assign the appropriate VLAN. So 10, 20, 30, 40, 50, and 99. I'm not gonna run this yet. I'm gonna say switch 2, and we're gonna do the same thing. First of all, we're gonna count. We need to FA05, so I'm gonna yoink that and paste it down here. So first of all, of course, we set all our ports to access VLAN 100, so a black hole. And then FA01 is PC2, that's VLAN 10. PC8 is VLAN 30. PC11 is VLAN 40. PC, oh my god, why is this cut off? To edit with external tool. PC, well, I could look at my own work here. Let's just scroll over. That's good. So, so we have FA04. That's that. We'll just go into preferences, or we show port labels in logical workspace, and we have FA04 here and FA05 here. So FA04 is PC12, PC12 is also 40, FA05 is PC13 is VLAN 50. And we'll do the same thing for switch 3, which only has 4 switch ports assigned to it. So we first of all, again, create our assign our black hole VLAN. And then we'll go switch port access VLAN. PC3 is an access VLAN 10. PC6 is an access VLAN 20. PC9 is in 30. And PC14, according to my beautiful graphic, is in 50. So, and now we're just gonna yoink this. We'll rename this to switch 3, otherwise I'm going to get confused. We're gonna yoink the switch 1 configuration, go in here, and just paste it. And then we're gonna go into, we're gonna grab our switch 2 hi cat, and exit here and paste it. And then we're gonna grab our configuration for switch 3, go in here, exit here, and paste it. So, and now we should have a fairly complete, yeah, we have 94%. I'm gonna check. So my PCs are correctly connected, all of them. The native VLAN is not set, connects to fast Ethernet 23. Interesting, I seem to have broken that. Native VLAN is not connected, connects to fast Ethernet 23. We have to still do that. Apparently that is, I didn't do that correctly. So, fast Ethernet, I used fast Ethernet 22. Okay. Fast Ethernet 23. So now I have 97%. What is the next step in our wonderful objective? Assign an IP address to each switch. Yay. So what do we do when we assign a IP address to each switch? Well, that's a good question. Next question. We need to config an interface in VLAN 99. So we're in the VLAN 99, changed state to up. Okay. So we created an interface VLAN 99. This is a logical interface on the switch. And we assigned it an IP address, namely, according to my table, this is switch 2.192.168.0.2.10 slash, and now I have IP subnet mask. Okay, 255.255.255.248. Okay, I assigned an IP address to my switch. And the same thing here. Int VLAN 99. IP address 192.168.0.209. 255.255.255.248. And lastly, int VLAN 99 and IP address 192.168.0.211. 255.255.255. That's IP address 192.168.0.211 is switch. Yes, 255.255.255.248. Okay, and shutdown would shut it down, right? Yeah, no shutdown. No shutdown should not do anything now. Yes, good. Change state to up. Interface VLAN 99. Cool. We assigned every switch an IP address. Configure trunks between the switches, including the native VLAN. So now is the fun part. We're on switch 3. I actually want that, but I want this. Switch 3 connects to switch 1 via FA21. So we need to configure interface FA021. And we need to say switch port mode. Instead of access, this time we say trunk. And it's confused now. Oh my god, what was that? Oh, it's just Discord. Okay. Hello. Right. Switch port mode trunk, switch port. So we made a trunk port here. We'll say switch port trunk allowed all. No. VLAN all. Because of course it is. Switch port trunk, and then we have to set the native VLAN to be 75. What is the native VLAN? Well, that's just when an untagged packet comes in, like an ARP request, I think is untagged. It'll go through the native VLAN instead, I think. Actually, I'm not sure anymore. Regardless, we have to do this on every switch port. So int interface FA021 FA21 switch port mode trunk switch port trunk allow VLAN all switch port mode switch port trunk native VLAN 75. And then we need the interface FA23. We need to set switch port mode trunk. We need to allow VLAN all, and we need to set the native VLAN. And then switch 2 is going to complain, oh my god, we have inconsistent port types. So again, interface FA023 switch port mode trunk switch port trunk allow VLAN all switch port trunk native VLAN 75. And I'm at 100%. Great. So that was the main thing. Setting up all the trunk switches from PC4 to try to ping PC6 and PC1. We can do that for sure. This is PC4. We'll once again ping PC6, which works because obviously they're in the same VLAN, in the same group, and PC1 doesn't work because it's not in the same VLAN, and it's not even in the same subnet, so it won't work unless we add a router, which we will not do. Okay, same as before. There is no routing, so PC4 and PC1 cannot communicate. PC4 and PC6 can. So, document the VLAN configuration to. Oh, the funs. I love documenting VLAN configurations. So, that is. I think I can leave this as an exercise to the reader. Define VLAN and explain its purpose in network segmentation. Well, VLAN, this is bold, I don't like bold. A VLAN is a way to have multiple subnets on a switch without them being able to know that other subnets exist. In this case, a VLAN would not transmit, would be assigned to a port, and that port does not relay information to other VLANs as they are separated, so not even an ARP request would arrive. Describe the process of creating a VLAN on a Cisco switch. Enable. No LibreOffice. I do not want it to be capitalized. Config terminal. Config term. VLAN number. Name VLAN name. I am lazy today. Okay, VLAN name. This creates the VLAN number and assigns it a name, VLAN name. It doesn't, however, do anything at this point yet, unless you assign it to a port. What is the native VLAN and why is it important? I knew that at some point. It's been so long. A native VLAN. It's again bold. I don't like that. A native VLAN serves as the default communication route between multiple switches. Oh my god, this took me an hour. A native VLAN serves as the default communication route between multiple switches. If a switch, for example, needs to communicate to with and no, this makes no sense. Native VLAN. Default VLAN and native VLAN. That sounds fun. VLAN 1 is default VLAN, which is needed for many protocol communication. You can't change or even delete the default VLAN, it is mandatory. Okay. The native VLAN is the only VLAN which is not tagged in a trunk. In other words, native VLAN frames are transmitted unchanged. Okay, but default native VLAN is VLAN 1, but you can change that. That is fine. Okay. If a packet is not transmitted from a port with VLAN, it is sent via a trunk port, it wouldn't be tagged. It would, however, be automatically part of VLAN 75. Wouldn't be tagged, however, it would be automatically part of VLAN 75. Or in our case, or whatever the case and native VLAN would be. So, I think that's everything. Questions?